This is Advanced Math 8.4 notes. Title is Difference Quotient. First part is review. Given f of x equals 5x minus 2, find f of 3. Do you guys remember from previous math classes what it means to find f of 3? It doesn't mean f times 3, right? You learned that back years ago. This notation does not mean f times 3. What does f of 3 mean? Colin, can you tell us what f of 3 means, the notation?
Is it just finding for y?
You're finding y, so what do we do with the 3?
Plug it in.
Plug it in. So we're going to take 5. We're going to write it 5 blank minus 2. I call this the skeleton form. 5 blank minus 2. And then I plug in what they're telling us, the 3. Plug it in. And what do you guys end up with as an answer? Sophia, what do you end up with as an answer?
13.
13. Do you guys all agree? Yes? Okay. And again, that's most likely review for middle school. Okay. Let's do f of a. Same concept as what Colin said. You plug it in, and same, what I'm going to do is what I said before, what I call the skeleton form, f of blank minus 2. And we're going to do that a lot. Not f of blank, sorry, 5 blank. 5 blank minus 2. We're going to do that a lot, like set up the function with blanks wherever x is, 5 blank minus 2. And in this particular problem, we are plugging in a. 5 times a is a, and 5a minus 2 are not like terms, so that's as far as I can go. Questions? Okay, next one, f of x plus h. And again, I want you, I don't care how easy it is to get used to doing, again, what I call this skeleton form. This 5 blank minus 2. What goes in the blank? Good. Harris, what goes in the blank? X plus h. And then we are going to distribute the 5. 5x plus 5h minus 2. Are any of these like terms? No? That there is my answer. Make sense? Okay. Any questions on the review? Okay. This next piece is where the new stuff begins. Definite on the test. Find the difference quotient and simplify. Find the difference quotient and simplify. Okay. Number 1, f of x equals 5x minus 2, comma, f of x plus h minus f of x all over h such that h does not equal 0. Okay, so when you have difference quotient problems, and these will come up over and over, it's always going to be set up like this. You don't ever have to memorize a formula. You don't have to memorize, like, this is a difference quotient formula. They're going to give that to you. They're going to give you a function of x. They're going to give you the difference quotient. And that notation, don't worry about it. Why did they give it to you? Because it's a fraction, and can I have a 0 in the denominator? No, so h cannot equal 0. Okay, so you don't have to memorize anything here, like they're going to give you this, they're going to give you this. You need to know how to plug it in and simplify. Okay, so this is the piece we're going to work with. And since it's a fraction, and I'm going to be plugging things into it, I'm going to make a big exaggerated fraction like this with the h at the bottom. All right, and here, like the skeleton form that I talked about earlier, we're going to do that again. Now, do you see where I have this f of x plus h minus f of x? That's what I'm going to have at the top, f of x plus h minus f of x. Now, since this piece here is to the right of the minus sign, I always have to put it in parentheses. I'm going to put it in red so you can see it. That always goes in parentheses because I will have to distribute the negative. All right, now what I'm going to do next is on the top of each one, just remind you which one's which. The first one is f of x plus h, and the second one is what? F of x. Okay, so this big fraction is just this, f of x plus h minus f of x all over h. It's the big skeleton of this form here. And now, inside, I'm going to set up another skeleton for the 5x minus 2. And it's going to look like this. 5 blank minus 2, 5 blank minus 2. So it's kind of a skeleton within a skeleton. So you're going to do this every single time. The first part is setting up your big fraction, and the second part is plugging in your f of x into the big chunky pieces. But when you plug in your f of x, you plug it in without the x's. 5 blank minus 2, 5 blank minus 2. And in this first one, what am I going to drop in? Now, Mandeep, can you tell me for this first one what I'm going to drop in here to the parentheses where the x used to be?
Is it the x plus h?
It is indeed the x plus h. And Izzy, can you tell us for the second one what I'm going to drop in here where the x used to be?
Is it the other function?
It's right here. Just the x. I know, it's a little too easy. We just drop in the x. So this one, I am going to have to distribute the 5. 5x plus 5h minus 2 minus parentheses 5x minus 2 all over h. What am I going to have to do? I said it earlier. The whole reason I put those parentheses there was to remind you to do what with that negative sign? Distribute. All right, you guys need to be paying attention. 5x plus 5h minus 2 minus 5x plus 2 all over h. At this point, you should be able to combine like terms, and a lot of things usually cancel out at this point. 5x and negative 5x, negative 2 and positive 2. Do those terms cancel out? Yeah, 5x and negative 5x gone, negative 2 plus 2 is gone. What does that leave me with in the numerator? 5h in the denominator. And that reduces to what? 5. It should always reduce. If you don't reduce, you've done something wrong. All right. Any questions? Okay, ready to move on? Anybody need this page up a little bit longer? Number 2. F of x equals x squared minus x minus 4. The difference quotient is f of 2 plus h, close parentheses, minus f of 2, close parentheses, all over h, such that h does not equal 0. Okay, so again, you always work with this fraction as the big, that's your original big skeleton form that I call it. Big fraction, big chunky piece minus big chunky piece. And I always put parentheses on my second big chunky piece because I will have to distribute the negative eventually. Maybe, sometimes I combine like terms over here and I don't have to distribute sometimes. But here, I definitely had to distribute the negative. So I always put the parentheses there as a reminder. All right. And then I also put up here as the reminder, this is my first piece, so f of 2 plus h. Second piece is f of 2. And you can see where the setup is the same. There's a chunky piece minus a chunky piece over h. There's a fraction, but what I'm plugging in is different. So they're not always going to look exactly the same. The setup's similar, but the work is a little different. And the f of x function is different as well. Okay, questions on the original setup that I did. The skeleton form, as I call it. Any questions on the original skeleton form? Okay, second part of the skeleton form is here. F of x goes inside with blanks. Blank squared minus blank minus 4. And again, blank squared minus blank minus 4. Now I want you in here to plug in whatever should be plugged in for the blanks, and in here whatever should be plugged in for the blanks, and then check with your shoulder partner and see if you've plugged in the correct thing. Check with your shoulder partner. You guys should be checking each other. Robbie, I'm going to have you take off your hood, please. Okay. Brinley, can you tell me what you plugged in for these two parentheses?
2 plus h.
Thank you. Did everybody else plug in 2 plus h? Yes? Okay, and Oscar, can you tell me what you plugged in here? 2? All right. So this one does require a little more work than the previous problem. And one of the main reasons why, well, first there's more inside the chunky pieces, but right here, do you see that quantity squared? Can I distribute the exponent and put that as 2 squared plus h squared? No. This piece here I have to write it as 2 plus h quantity squared. Do you guys agree with that? And I wrote that wrong, sorry, because that's the same exact thing. How do I write that? 2 plus h times what? Anybody remember? What does that mean? 2 plus h times? Thank you. And what's the math word I'm looking for? Starts with the D. Distribute, double distribution. Good. So do that now. Do your double distribution. Some of you do it all in one step. Some of you do it step by step. Do whatever you do. Do your double distribution all in one step. Double steps, however you do it. And then here on the next one, you're just going to distribute the negative. All right. Does anybody have this distributed and already the middle terms combined? Can I have a volunteer give it to me? Already distributed and the middle terms combined. Nobody's going to volunteer. Good job. Who gave it to me? Okay, she said h squared plus 4h plus 4. Did anybody else get that? Did anybody write it with the 4 first? Okay. She wrote it in the correct form. When you FOIL it or double distribute it like this, do you get 4 plus 4h plus h squared? The way you gave it is perfectly fine. I'm going to write it like this just because that's the way it comes out. The other way is perfectly fine as well, so don't change yours. Okay, is that what you guys got? All right, so minus 2 minus h, because that's what you get when you distribute the negative, minus 4 minus, I'm going to distribute the negative here. What's 2 squared? 4. So I'm distributing the negative here, here, and here. Minus 2 or plus 2? Plus 2. Minus 4 or plus 4? All right, go ahead and combine like terms. A lot of things cancel out. I will tell you this, once everything cancels out, you should be left with 2 terms. And if you've gone far enough, the 2 terms you're left with should have a GCF. All right. What happens with the 4s? This 4 and this negative 4, does that cancel out? Okay, 4h doesn't. Do the 2's cancel out? Do these 4's as well cancel out? All right. H squared and 4h and negative h, what does that combine to? 3h. So is that what we're left with in the numerator, h squared plus 3h? Yes? Do you guys have a question for me? Go ahead. No question? No. Okay. Sophia, you're good? All right. Now, I'm not done, because what was the hint I gave earlier? I said when you're done with your last 2 terms, you can do what? Factor out of GCF. What's my GCF? H plus 3. And then what reduces? And what did I say earlier? At the end, you should always be able to reduce. If you don't reduce, you've done something wrong. What's my final answer? Any questions? So yes, there's quite a bit of work, but all the work in here is work you've been doing from previous math classes. It's just putting it together that's new. Like putting it here and da-da-da-da-da, but everything else is review. Any questions? Does it make sense?